In the far south, where the wind sounds like an endless organ note and the sun circles instead of setting, human imagination fills the cold with shapes. A satellite image looks like a triangle. A ridgeline seems too straight. A snow shadow becomes a doorway. In a place almost no one will visit, the mind sketches stories between pixels. This film follows those stories to the limits of evidence. It begins with a question so simple it almost feels forbidden. Could there be engineered structures, pyramids, corridors, foundations, hidden in Antarctica's ice? The answer is not a single word. It is an expedition through geology, glaciology, satellite artifacts, polar history, and our deep hunger for pattern. First, a map. Antarctica is two continents disguised as one. East Antarctica, a thick, ancient craton armored in kilometers of ice, and West Antarctica, a collage of mountain chains and rifted basins partially below sea level. Between them rises the Transantarctic Mountains, a chain longer than the Rockies, its peaks poking through ice sheets like islands of rock in a frozen ocean. Where rock breaches the ice, wind carves it. Snow drifts and scours, sun angles sharpen shadows, and suddenly a mountain flank looks like a clean triangle. If it were Egypt, we would say pyramid. Here we say pyramidal peak, a known alpine landform created by multiple glaciers eroding a mountain from different sides until only a pointed horn remains. Seen from orbit with low sun and high contrast, these horns become pyramids in the human eye. Still, some images seem audaciously regular. A famous example circulates with labels like Antarctic Pyramid, usually traced to a nunatak in the Ellsworth or Heritage Ranges, or to the vicinity of the Shackleton Range. The triangular face is striking, but regularity in nature is not a miracle. It is an outcome of repeated forces. Freeze-thaw cycles exploit cracks called joints, producing planar facets. Directional winds abrade snow into sastrugi that emphasize straight lines. Glaciers grind along bedrock with a steadiness that would make a surveyor envious. Triangles, hexagons, spirals, geometry is not proof of intention. Basalt columns form hexagons without architects, snowflakes trace six-fold symmetry without blueprints, dunes march in parallel without a general. The Antarctic pyramids live in that company of alluring order. A second set of claims leans not on shape but on alignment. Enthusiasts plot coordinates from Google Earth and extend great circle lines toward Giza or Teotihuacan. Some alignments do exist because alignments always exist when you draw enough lines on a sphere. The Earth is generous with coincidence. If you select 3 triangles from thousands of peaks and look for a fourth that sits on a great circle path to a famous monument, you will find one. The test is not whether lines can be drawn, but whether the lines carry independent evidence, inscriptions, artifacts, datable human activity, consistent survey baselines, a cultural context that explains why a Bronze Age or earlier civilization will cross an ocean of ice to place a stone at 40 below zero. Without that context, alignment is cartographic pareidolia, the map version of seeing faces in clouds. The continent's age, however, allows a different, subtler mystery. Antarctica was not always a polar desert. In deep time, back when Gondwana was whole, trees grew where now there is only wind-scoured rock. Fossil forests have been found, stumps still rooted where they once lived, their rings telling stories of long seasonal light rather than constant summer. This does not imply an ancient city buried under kilometers of ice. It implies that climate is not static, and that the planet's plates carry continents into different latitudes like slow rafts. The presence of ancient trees proves warmth without proving architects. It reminds us that the present ice cover, up to nearly 5 kilometers thick in places, is a geologically recent veneer. Anything we imagine at the base of that veneer must have survived millions of tons of flowing ice and a sandpaper of embedded stones. Stone pyramids do not survive beneath glaciers. Mountains do. Some mysteries belong to the sensors. Remote sensing satellites are magnificent. They are also imperfect. A microwave instrument maps bedrock through ice by measuring the travel time of reflected pulses. A radar swath stitches many passes into a mosaic. Between passes, the satellite's angle changes, the surface roughness changes, the ionosphere wobbles, and the software guesses. Guesses leave seams, straight edges, regular grids, rectangles of no data tinted as if they were real terrain. In optical images, low sun produces long shadows. A simple brightness and contrast boost can turn a gentle slope into a knife edge. An auto-sharpen filter exaggerates lines that were never there. A JPEG compressor saves bandwidth by turning gradients into blocks. Blocks become bricks in our minds. Before building a theory on a screenshot, polar scientists ask a dull question that saves lives. Which sensor, which pass, which processing chain, which error bars? Beneath the ice lie lakes and mountains that sound like myth but are solid science. Lake Vostok, larger than some European countries, sleeps under nearly 4 kilometers of ice. Its waters have been sealed for hundreds of thousands of years, maybe more, warmed from below by geothermal heat and insulated from above by the ice blanket's pressure. Radar maps reveal subglacial river networks and valleys, some aligned with the ghosts of ancient mountain chains. If you want an Antarctic corridor, look at these rivers, dark lines in radar where ice glides more quickly over lubricated beds. They are natural highways, guiding ice flow as surely as gravity guides water. And if you want a dome, look at the ice's own surface. It rises into broad divides where accumulation outpaces flow and falls into troughs where katabatic winds strip snow away. The geometry is grand, arches, ridges, basins, and yet it is the arithmetic of snow and time. History, too, adds a layer of romance that demands careful reading. Tales of Nazi expeditions, secret bases, and post-war hideouts flourished after 1945. There were real expeditions, driven by whaling interests and national prestige. There were also real bases, scientific huts and fuel caches, established by many nations in the scramble to explore and claim. But the notion of a self-sustaining, hidden fortress beneath the ice collapses under logistics. Anything habitable in Antarctica must be flown, shipped, or hauled in, then maintained against cold that breaks metals and winds that sandblast paint. Today's modern stations depend on seasonal resupply and redundant power systems. Yesterday's fantasies would have required miracles of engineering unrecorded anywhere else. Secrecy exists, of course. It stretches over defense satellites and encrypted data links. But secrecy cannot conjure cargo tonnage from thin air. A different historical thread invokes an older map, the Piri Reis chart, a 16th-century portolan that some claim shows an ice-free Antarctic coast. The chart does show a southern landmass, but cartographers point out that medieval and early modern maps often included speculative coasts based on travelers' tales or the symmetry of imagination. Terra Australis was a balancing fiction meant to counterweight known continents. The southern coastlines on such maps usually fuse parts of South America, mythical islands, and guesswork. Reading precise glacial margins into them asks a handmade map to behave like a satellite. It cannot. Yet mystery persists because Antarctica's data gaps are real. Most of what we know comes from relatively sparse traverses, aircraft surveys, satellite overflights, and a handful of drilling projects. The scale is brutal. Your city would be a dot. Your nation might be a polygon. Even a dense airborne radar campaign maps a swath tens of kilometers wide and then leaps hundreds of kilometers to the next one. Interpolation, filling the gaps between swaths, is powerful but not omniscient. Where the gaps are large, rumor pours in. In such places, it is reasonable to say, "We don't know the exact bedrock shape here," and unreasonable to leap from that sentence to therefore, something engineered is hidden under the ice. Let us walk slowly through a specific pyramid. Imagine a nunatak protruding from a plateau, its summit approximately 1,500 meters above sea level. On its north face, the rock is planar, a product of jointing in the metamorphic bedrock. Two glaciers flank it, carving cirques that bite from different directions, sharpening the ridge into an arete. Over tens of thousands of years, frost shattering removes blocks along the joints, leaving a facet that tilts at roughly 40 degrees, the natural angle of repose for unstable debris. From one vantage, the three main facets meet at a near-perfect apex. From another vantage, the illusion collapses. The fourth face is broken by a buttress. The summit is a ridge, not a point. Now add seasonal snow. Wind scours one face clean and deposits on another, accentuating angles. At sunrise, the shadow edge looks machined. At noon, the machine marks melt into slopes. If you freeze the dramatic hour and crop to remove the messy flanks, your image will sell a story more exciting than the geology. But the mountain did not change. The camera did. Some viewers counter. What if the pyramid is mostly buried, with only the tip visible? If a civilization erected a large stone structure millions of years ago, kilometer-thick ice would deform and overrun it, grinding at its edges with basal rocks hard as teeth. Even granite yields to that kind of dental work. The shape that survives beneath is the bedrock hill itself, drumlinized by flow. If the structure were metallic, the story grows stranger. A metal dome would respond to temperature cycles differently than rock, likely fracturing the ice around it, producing a radar bright spot with a distinctive signature. We do see bright spots. Most correspond to wet patches, bed roughness, or subglacial lakes. None yet require steel or alien alloy to explain them. Subglacial volcanism offers a richer source of real geometry. West Antarctica sits atop a rift system peppered with volcanoes, many of which lie under ice. Some produce conical edifices. Their symmetry can be exquisite, their craters tidy bowls. A basaltic cone poking through snow looks like a textbook triangle from a glancing angle. It is engineered by mantle heat and gravity, not by masons. On radar, volcanic edifices can form ring-like echoes from layered ash and ice. When these rings intersect a flight line obliquely, they appear as straight segments. Stack enough segments, and an over-enthusiastic eye can trace corridors and chambers. If the ground story is geology, the human story is yearning. Pyramids attract us because they combine mystery with simplicity. A pyramid says, someone was here, and they knew how to bind gravity to will. In a world where most landscapes are indifferent to us, a pyramid is a finger lifted by intention. Antarctica is the opposite, an entire continent indifferent to us. The idea of a pyramid there is comforting. Even here the story is about us. A better comfort, perhaps, is that Antarctica's natural architecture dwarfs ours in beauty and scale, and does not require us to be at its center. Still, the possibility of discovery is not closed. Under the ice, on rare blue ice fields, meteorites collect, blown by wind and trapped by subtle flows. Each season, teams recover pieces of other worlds. On nunataks, ancient rocks speak of supercontinents assembling and breaking. At the ice sheet's base, sediments bearing fossil DNA might reveal vanished ecosystems that thrived before ice sealed the door. In coastal zones, radar has traced buried canyons deeper than the Grand Canyon, cut by rivers that flowed when Antarctica's climate was a different sentence altogether. None of this is less wondrous than a speculative pyramid. All of it is demonstrable, datable, and surprising in ways that make science feel like myth that just learned to keep records. Internet-age myths often rest on two pillars, an arresting image and an absence of context. The cure is not to snuff out wonder but to give it better fuel. If an image shows a triangular nunatak, link it to a geological map with rock types labeled. If a claim mentions a doorway, check multi-year imagery to see whether the door migrates with the snow. If a corridor appears in radar, examine adjacent swaths to see whether it is a scene between data tiles. If a line on a map seems to aim at Giza, test thousands of random lines to see how many hit a monument by chance. If someone cites a source, ask whether the source is the original data or a summary of a summary passed through a layer of dramatic music. The Antarctic Treaty System, which governs the continent, is not perfect, but it is one of humanity's better ideas, a whole landmass dedicated to peace and science. Under the treaty, nations inspect each other's stations, report activities, and share in the painstaking work of mapping, measuring, and monitoring. When an unusual feature turns up in data, it often becomes a multinational conversation. Teams compare instruments, models are tested, flights are redirected, hypotheses are refined, results are published with methods sufficient to let other people check them. That plodding transparency is the opposite of the secret base romance and therefore less likely to trend. But it is how truth keeps a tent upright in high wind. What then should we say to the persistent idea of Antarctic pyramids? We can say that Antarctica holds peaks that look like pyramids because glaciers carve horns in plains, that regularity is expected in jointed rock, that optical tricks and data seams amplify neatness, that subglacial landscapes include lakes, volcanoes, and canyons whose geometry is natural but arresting. That no artifact-level evidence, tools, inscriptions, cultural deposits, has been recovered to support engineered megastructures, and that if such evidence ever appears, the scientific community would not be able to hide it for long because careers are made by firsts, not by silence. We can also say that mystery is not a finite resource allocated only to conspiracy. The aurora over the polar plateau, the blue sound of ice cracking, the way a petrel finds a patch of open water in 100 leagues of white, these are daily miracles. The geometry people seek in triangles is present in the equations that keep katabatic winds accelerating and in the crystal habit of snow under pressure. If you must have a pyramid, stand at the foot of a tabular iceberg whose calved face is a perfect plane the size of a city, then follow its shadow across an ocean. The builders were temperature, salinity, pressure, and time. Future missions may drill deeper lakes, fly finer radar, and map bedrock with resolutions that turn hints into portraits. With each technological step, two things will happen. Structures we once imagined will dissolve into the grain of natural process, and phenomena we have not yet imagined will take their place as the newest puzzles, equally beautiful, equally resistant to easy answers. That is not disappointing news, it is the adventure we are actually on. In the end, Antarctica's mysterious pyramids tell us less about the continent than about ourselves. We want intention where there is pattern. We want a message where there is symmetry. We want an author where there is law. The ice answers with an older voice. Gravity is enough. Pressure is enough. Sunlight at a low angle is enough. The triangle you love is a mountain surviving the long patience of weather. The corridor is a radar seam. The doorway is a drift that moved after the last storm. The mystery is not banished, it is relocated. It lives in how forces as simple as freezing water and blowing wind sculpt art at planetary scale. If someday a team returns from a nunatak with a carved stone whose isotopes say it was quarried and placed by hands, the story will change, and this film will become the preface to a better one. Until then, the best story we can tell is already extraordinary. A continent of mountains wearing a crown of ice, lakes locked under pressure for ages, volcanoes burning secretly beneath snow, and a global polis that agreed, against habit, to keep one vast place for science. On that stage, triangles are not signatures, they are reminders that order is not owned by architects. Nature draws straight lines when she wishes, and in Antarctica she has all the time she needs to draw them.